At sea, nothing moves faster than light, and this time, the United States Navy didn't just talk about it, didn't just test it, and didn't just promise it. It used it. No missile launch, no explosion, no warning shot. 4 aerial drones entered a naval engagement zone, and 4 drones never left it. They were erased silently, one after another, by a beam you couldn't hear, couldn't outrun, and couldn't jam. No smoke trail, no radar warning, just instant destruction. And that single moment may have changed the future of naval warfare forever. Because for the first time in modern military history, a directed energy weapon didn't just prove it could work in theory, it proved it could fight, survive, and win in a real operational environment. This wasn't a laboratory test. This wasn't a controlled range experiment. This was the real world, real threats, real consequences. What if I told you the US Navy now has a weapon where every trigger pull costs less than a cup of coffee, yet it can defeat threats designed to sink billion-dollar warships? What if I told you this weapon fires at the speed of light, cannot be intercepted, cannot be outrun, and doesn't care how many targets come at it? And what if I told you this isn't a future technology, not a prototype, not a concept slide buried inside a Pentagon briefing? It's already deployed, already firing, already rewriting the rules of naval combat. To understand why this moment matters, you first need to understand the threat the Navy is facing right now. Modern naval warfare is no longer dominated by massive fleets crashing into each other with capital ships and heavy missiles. Today's battlefield is asymmetrical, cheap, relentless, unforgiving. Adversaries no longer need advanced fighter jets or submarines to threaten a warship. All they need are drones, commercial quadcopters modified to carry explosives, cheap fixed-wing UAVs converted into one-way attack platforms, loitering munitions that cost a few $1,000s but can force a multi-billion-dollar ship into defensive panic. These drones fly low to avoid radar, they fly slow to confuse tracking systems, and most importantly, they fly in numbers. 1 drone is a nuisance, 5 drones are a distraction, 20 drones are a problem. 50 drones launched simultaneously from different directions turn into a strategic nightmare. Because modern warships rely on layered defenses built around missiles, and missiles are expensive. A single interceptor missile can cost hundreds of thousands, sometimes millions of dollars, and every ship carries only a finite number of them. This is where the math of modern warfare completely breaks down. Imagine firing a $2 million missile to destroy a drone that costs $20,000. Do it once and commanders accept it. Do it 10 times and budgets start bleeding. Do it until your missile magazines are empty and suddenly your ship is naked in contested waters. This is the cost exchange problem, and it has haunted naval strategists for over a decade. Missiles run out. Reloading at sea is slow, dangerous, or impossible. And once your magazines are empty, the enemy doesn't need to sink you, they just need to overwhelm you. Saturation is enough. This is exactly the gap the Navy's laser weapon was designed to close. Quietly, methodically, without the dramatic flair of a missile launch. This system doesn't scream power, it whispers inevitability. The Navy calls it a high-energy laser weapon system, and its purpose isn't intimidation, its purpose is economic warfare. Because this weapon doesn't fire ammunition, it fires electricity. No rocket motors, no explosive warheads, no guidance fins. Instead, powerful onboard generators feed massive electrical energy into a tightly focused beam of light. That beam travels instantly. It doesn't arc, it doesn't drop, it doesn't miss once the system locks on. When it strikes a drone, it doesn't blow it apart in a cinematic fireball. It does something far more efficient. It cooks it. Sensors overheat first, cameras go blind, control electronics fail, wiring melts, structural components weaken, control surfaces seize, and then gravity does the rest. The drone falls out of the sky, already dead, before it ever hits the water. One beam, one target, one kill. And the moment that engagement ends, the system immediately shifts to the next threat. No reload, no pause, no human scrambling to prepare another weapon. The laser simply keeps firing. During the recent engagement, 4 unmanned aerial systems approached a U.S. Navy vessel operating in a real threat environment. Individually, none of them were impressive, but together they represented the exact strategy modern adversaries are betting their future on: cheap systems designed to exhaust expensive defenses. The ship's sensors detected the first drone, the laser tracked it, the beam fired, the target failed. Seconds later, a second drone entered range, another lock, another beam, another kill. Then a third.
Then a fourth. 4 drones destroyed in sequence without launching a single missile, without spinning up close-in guns, without revealing the ship's position through massive radar emissions. Just sustained, precise, controlled energy. This wasn't a test range. This wasn't a scripted demonstration for cameras. This was a live, operational scenario, and the weapon performed exactly as intended. After the engagement, senior Navy officials confirmed the event publicly. They described it as a milestone, marking the transition of laser weapons from experimental curiosities to operational combat systems. One defense official stated that this capability fundamentally changes how naval forces defend against low-cost aerial threats. That sentence carries enormous weight. Militaries do not speak in absolutes unless doctrine is about to shift, and this shift is massive. Every missile not fired is a missile saved for a higher-end threat. Every drone destroyed by laser preserves a ship's combat endurance. This weapon flips the cost equation entirely. The attacker no longer wins by being cheap. Now the attacker bleeds resources while the defender spends almost nothing. Drone swarms lose their strategic advantage. Saturation attacks lose their credibility because you cannot overwhelm a system that doesn't run out of ammunition. But this isn't a fantasy shield, and the Navy knows it. Lasers have real limitations. Weather matters. Heavy rain, fog, dust, or sea spray can reduce effectiveness. Engagement time matters. Power generation matters. Against hardened, supersonic anti-ship missiles, lasers are still part of a layered defense, not a standalone solution. But against drones, small boats, sensors, and soft targets, they are brutally effective. And most importantly, they are improving. The system used in this engagement is not the final version, it's the starting point. The Navy is already increasing power output, improving beam control, integrating laser weapons directly into combat management systems, and linking them with radar and electronic warfare suites. Future variants will engage targets faster, at longer ranges, and with greater lethality. Over time, lasers will defend destroyers, cruisers, carriers, and amphibious assault ships. Entire fleets will be protected by weapons that never need reloading. This moment will be remembered not because 4 drones were destroyed, but because it marked the point of no return. Naval warfare has entered the age of directed energy. Speed of light engagements, near zero cost per shot. Defenses limited by power generation, not ammunition storage. This isn't science fiction, it's doctrine in motion. And if you want to understand where modern warfare is going, not next decade, but next year, you're in the right place. Subscribe now because the battlefield is evolving faster than ever, and the next weapon to rewrite the rules is already charging up.